Hello guys, welcome to our channel. The topic before you is Jacobian. The Jacobian is a mathematical concept in calculus and linear algebra. A Jacobian matrix named after the mathematician Carl Gustav Jacob Jacobi refers to the matrix of partial derivatives of a set of functions. The main use of Jacobian is found in the transformation of coordinates. From what we have discussed so far, a Jacobian can be represented in this form. From what we have here, f1, f2, and f3 are functions having the variables x1, x2 down to xm. Mind you, whenever you are looking for the Jacobian of a matrix, you first look for the differential of the first function with respect to the first variable. Still on the same first function, you look for the differential of that same function with respect to the second variable. If you have a third variable, you look for the differential of that same function with respect to the third variable, now down to the last variable. You come down to the second function. You look for the differential of the second function with respect to the first variable. Next, you look for the differential of that second function with respect to the second variable. Like I said, if there is a third variable, you look for the differential of that second function, which is cf2, all over the third variable down to the last variable. Now for the third function, you look for the differential of the third function with respect to the first variable. Next, you look for the differential of that third function again with respect to the second variable, now down to the last variable. The determinant of the above Jacobian matrix is called a Jacobian. For example, let's say we have a function f of x comma y which is equal to u x comma y comma v x comma y. Now this is a function having two variables x comma y. Now this function is being represented by these other two functions u and v. So looking for the Jacobian of this matrix, we have that j of x comma y is equal to, now like I said before, you look for the differential of the first function with respect to the first derivative. So you have du over the x. Still on the same first function, you look for the differential of that same first function all over the second variable, which is du over the y. Now down to the second function, we have dv over the x and dv over the y. The determinant of this Jacobian matrix, which is det of j, is equal to the absolute value of du over the x, du over the y, dv over the x, and dv over the y. Now whenever you are looking for the determinant of a matrix, the determinant of a matrix is the product of the principal diagonal of a 2 by 2 matrix is the product of the principal diagonal minus the product of the minor diagonal. From what I have talked about so far, the determinant of this matrix is du over the x times dv over the y. Du over dx and dv, this is the principal diagonal and this is the minor diagonal, minus the minor diagonal, which is du over the y times dv over the x. So whatever you get as the answer is the Jacobian of whatever function you are given. Question 1. Given this particular problem, where x is the first function and y is the second function, we are being told to find the Jacobian of this particular problem. So first thing first, look for how to represent this particular Jacobian. So we have that j of u comma v is equal to, now look for the x over the u and the x over the v. Now on the second function, we look for the y over the u and the y over the v. Now the x over the u is equal to 2u minus 0. The reason is because when you differentiate this particular function with respect to u, we have 2u minus 0 because this v square is a constant, and now differentiating a constant is 0. In case you don't know how to look for your partial derivative, I'll be dropping a link in my description below so you can go and see about that. Now the x over the v, we are still talking about this particular function. The x over the v is equal to 0 minus 2v. Now v is now what? The variable we are dealing with, and because we have a different variable here, it will be known as the constant. Now if you differentiate a constant, like we said before, it will give you 0. And now differentiating v squared with respect to v, we have negative 2v. Now to the function y, looking for the y over the u. Now differentiating this function with respect to u, this means that u is being reduced by 1, so we have 2v. And differentiating the function with respect to v, it means that v is being reduced by 1, so we have 2u. Now representing all of this into this place, we have 2u, the x over the u is 2u because 2u minus 0 is 2u, and the x over the v, which is 0 minus 2v, and 0 minus 2v will give you negative 2v, and the y over the u is equal to 2v, the y over the v is equal to 2u. So we have 2u multiplied 2u, which will give us 4u squared, minus negative 2v times 2v will give us negative 4v squared. So in other words, this will now give us 4u squared plus 4v squared. Question 2. We have the function x, which is equal to uv, and another function y, which is equal to u plus v. Find the Jacobian. Now why not you pause the video and try and work out this by yourself. Making reference of this particular problem, this representation is similar to this particular problem. So first thing we need to look for is the x over the u. Now differentiating x with respect to u, we have v. And differentiating x with respect to v, we have u. When you differentiate x with respect to u, now u is being reduced by 1, so we have v. And whenever you're differentiating x with respect to v, v is being reduced by 1, and you still have u. Now differentiating y with respect to u, we have 1, simply because if we differentiate this function u with respect to u, we have 1, and if we differentiate this function with respect to v, we have 0. So we have 1 plus 0, which is equal to 1. And looking for the y over the v, when you differentiate this function with respect to v, u automatically becomes 0, and v is equal to 1. Hence, looking for the determinants of this particular problem, we have v times 1, which is v, minus 2 times 1, which is u. Question 3. If x is equal to r cos theta and y is equal to r sin theta, find the Jacobian. First, you need to represent this particular problem in this format, where we have the differential or the first function with respect to the first variable and the differential of the same first function with respect to the second variable. The same thing for the second function. So the x over the r here, when you differentiate this function x with respect to r, we have cos theta. And when you differentiate the same function with respect to theta, we have negative r sin theta. Because differentiating cos theta, we have negative sin theta. Now the y over the r is equal to sin theta, because when you differentiate r sin theta, the r is being reduced, so what is left is sin theta. And differentiating y with respect to theta, we have r cos theta. Now putting all of this back into this place, we have cos theta minus r sin theta, and r cos theta. Now the determinant of this particular problem will now be the product of the principal diagonal minus the product of the minor diagonal. So cos theta times r cos theta will give us r cos squared theta minus r sin theta times sin theta will give us negative r sin squared theta. If you are new to our channel, subscribe, hit the notification bell such that whenever I drop a new video, you will be notified. From here, you should know that we need to factorize what is common, r. And by factorizing r, we have cos squared theta. Now negative times negative will give you positive. That's why I have plus here. So cos squared theta plus sin squared theta. Now remember that cos squared theta plus sin squared theta is equal to 1. Therefore, replacing all of this with 1, we have r in the bracket of 1. And r times 1 is equal to r.